before doing more examples with Snell's law, which essentially amount to some math problems, what I want to do is get an intuitive understanding for why this straw looks bent in this picture right over here. To do that, let me just draw a simplified version of that picture. So let's draw, this is the cup right over here. We'll do a side profile of the cup. So this is a side profile of this glass right over here. It's the best that I can draw it. And then let me draw the actual straw. So I'm going to first draw the straw where it actually is. So it's coming in off the side of the cup, and the straw is actually not bending. And it goes to the bottom of the cup just like that. And then it goes up like that, and then it goes slightly above it, and then it actually does bend up here, right over here. And then the straw actually does bend, but that is irrelevant to what we want to talk about. What I want to do in this video is talk about why when we look over here, why does it look like the straw got bent? And it all comes out of the refraction of the light as the light from the straw down here changes as it goes from one medium to another. Now we know from refraction indices, or just in general, that light moves slower in water than it does in air. So it's slower in water, and faster in air, So let's think about what's going to happen. Let me draw let me draw two rays that are coming from this point on the straw right over here. So if I draw one ray right over here, so I'm just going to pick an arbitrary direction. So if I pick one ray just like that, now, when it goes from the slower medium to the faster medium, what's going to happen to it? And it's at a slight angle here. So the left side of the ray is going to end up in the air before the right side. And I'm just using this as a way of, I'm using the car example to kind of think about which way this light's going to bend. So if you visualize it as a car, or sometimes people visualize it as a marching band, the left side of the marching band is going to get out before the right side, and it's going to start moving faster. So this is going to turn to the right. So it's going to turn to the right. Now let me do another ray. So let me do another ray that's coming from that same point. I don't want it to go right along the straw. So another ray just like that. It will also turn to the right. So it is also going to turn to the right. Now, if someone's eye is right over here, so that's your eye, that's the eyelashes, that's someone's eye. You can even draw their nose and all the rest. If they're looking down, where does it look like these two light rays? Let's say their eye is big enough that it captured both of these rays. Where does it look like these two rays are coming from? So if you trace both of these rays back, if you just assume that there was a line here, that's what our eyes and our brains do. If you assume that whatever direction this ray is currently going in is the direction it came from, and same thing for this magenta ray, and this magenta ray just like that, it would look to this observer that this point on the straw is actually right over there. And it would look, and if you kept doing that for a bunch of points on the straw, it would look like this point on the straw is actually right over here. It would look like we could do it for this point on the straw. It would look like that point on the straw is actually right over here. So to this observer, the straw would look like this. It would look like something. It would look something like that. It would look bent. This part would, even though the light from here is going up and then it moves out, because it gets bent, when you converge it back, it would converge to this, just like we saw with that first point. The light from this point, when it goes out and gets bent, if you were to just extrapolate backwards from their new directions, you get to that point. So to this observer, this point on the straw will look to be right over here, even though the light was emitted down here. And that's why the straw actually looks bent. So this is all really just because of refraction, from going from a slower medium to a faster one. So hopefully you find that a little bit interesting. In the next video, we'll actually do some examples with Snell's law just to get ourselves comfortable with the mathematics.